maybe.
Oh, I did it.
How do I drive it?
You do not assign. It has to move.
Okay. All right, so today I'm going to talk about ethical issues related to arbitrariness in automated decision-making systems and how these relate to these systems as they're deployed at scale. So imagine that we are in a nightmare, which is perhaps some people's everyday reality, which is that we have thousands of resumes, and out of these thousands of resumes, we're trying to find just 3 people to interview and 1 to hire. And we have all these constraints on our decision making. We have informational constraints, we have time constraints, and so we think maybe we should turn to some of these heavily advertised automated decision making systems like HireVue that use various pseudoscientific techniques like having people play little games or having them do a video interview. Maybe that's a good way to sort through these candidates. So I get all these data about these candidates from these tools, and with certain screening techniques, I'm able to say, well, maybe this tool is good because it does reduce certain kinds of bias compared to human hiring managers. It is able to respect the 4/5 rule, which not all human hiring managers do. So perhaps it increases diversity or mitigates bias. We're not sure. But at the very least, what using the system might do is increase standardization. So where before I had thousands of human hiring managers, now I have one system that I'm using across a wide variety of companies. So these automated decision-making systems standardize by enforcing the same classification on the same token applicant file every time it's encountered at scale. So the question is this standardization a problem? Should we think about this as a moral concern? So first I'm going to talk about this factor of arbitrariness. So imagine one of these automated decision-making systems is looking at my resume. There might be some correlations that I've learned between a feature and increased likelihood of rejecting a candidate. And some of these correlations might be biased, right? It might have a correlation between statistically associated with being a woman, like Kathleen, but some of them might just be arbitrary. So it might learn an association between being a double major in computer science and philosophy and rejection of candidates. And this kind of overfitting, where patterns that are present in the original data set, but maybe aren't very predictive about which candidates will be good under tasks in the wild, can lead to a certain kind of arbitrariness, where features that aren't very predictive are learned. So after thinking a little bit more about arbitrariness and whether it's wrong for individuals, then I'm going to look at whether arbitrariness at scale wrongs individuals, who is the person who might be arbitrarily excluded, and what are some things that we can do to address this problem. So first, do arbitrary decisions wrong individuals? So in order to answer this, we have to look at what kind of arbitrariness presents a moral problem. So one way we can interpret this is arbitrariness interpreted as unpredictability. And this doesn't seem like the moral problem. It seems like actors can permissibly choose to change their own goals. So let's say in the course of reading all the files, you realize, wow, I thought I was looking for this, but actually the candidates that are going to meet our needs are actually this other set of categories. The people who are in the hiring pool don't necessarily have the right or the ability to make a claim on you for that kind of predictability of decision making. So how about, if it's not arbitrariness interpreted as unpredictability, how about arbitrariness interpreted as a lack of constraint by rules? Well, this isn't the moral problem for algorithmic decision making. Even pseudo-random algorithms are still based broadly on rules. What about arbitrariness interpreted as sort of a lack of a good reason? this might be more promising. But if this is what we need, what kind of reason would we require in order to say that the hiring process wasn't arbitrary? So one idea is that maybe the reason provided needs to be public-oriented. So we could say, yes, you didn't get the loan, but that's because if loans were given to everyone with their qualifications, there would be so many defaults on loans that the housing market would collapse, and that would be bad for everyone. But it seems like it's too demanding to require that every action taken by private companies in hiring be justified by a public-oriented reason. Okay, so what about if the reason provided has to be good for the person affected? So if we gave you this loan, you would likely default, and that would not be good for you. You would have ruined your credit and set back your ability to attain financial stability given the system we have. That also seems too demanding to require that private employers and lenders always act for the benefit of applicants. So the third idea is that the reason provided must be good for the actor or decision maker. But this also potentially seems too morally demanding to require that agents act in their own interest. So it might be irrational for agents to fail to act in their own interest, but they don't owe it to the applicants to act in their own interest. So if this is true, then arbitrariness would be acceptable at the individual level. So if we're thinking about sort of the token-token relationship between one job candidate, and one hiring manager, if the demand that actors pursue their own goals in the manner best suited to their attainment isn't holding, then we have the first negative conclusion, which is that individuals are not entitled to non-arbitrary decisions unless some other kind of right guarantees it. For example, arbitrariness would not be the same as non-discrimination. So now we have this question, do arbitrary decisions at scale wrong individuals? So instead of looking at the token-token relationship, let's look at if the same decision is scaled out to be applied across the whole decision-making ecosystem. So here we might think we have reasons of democratic equality or relational equality to think that this would be a very bad thing. So in the relational equality framework, we typically say that it's okay for individual companies or individual organizations to rank candidates for opportunities by their own standards. So they can come up with their own rankings and use that to determine who gets certain opportunities. And individual people might have arbitrary preferences that guide their decision making. But if the same hierarchy or ranking is used across the whole sector, let's say a certain type of job, or across the whole geographic territory or area, given that people shouldn't have to move in order to have any opportunity, it can set the rules of interaction within a domain and monopolize access to opportunities. And so this consistent exclusion of the same people can lead to a pernicious social hierarchy, where the same people are being left out. Another way to think about that is in terms of autonomy. So sometimes people talk about autonomy as the ability to have access to, let's say, real choices, so not just pseudo choices. So if that's true, and autonomy requires access to a sufficient range of varied alternatives, such that choosing between them would provide some kind of meaningful choice about your life, then similar to this individual scale distinction, it's not a moral harm to deny just one alternative or one opportunity. So it can't be the case morally that you're owed every single thing that you apply for, but you need a range of alternatives, such as different opportunities that might give you genuine choices. And so it's what Joseph Raz calls a threshold harm to be denied a sufficient number of the possible alternatives. So if this system being scaled up means that you hit that threshold and you're denied a significant number of possible alternatives, that's where we would start to get concerned. So putting these two things together, we have the idea that systematicity is the moral problem. systematicity of arbitrariness is the moral problem, not the arbitrariness itself. So monopolies on opportunity can constrain autonomy in morally troubling ways. And when this limit on opportunity lacks even the instrumental rationality of it being good for the actor themselves, there isn't a justification for it in either epistemic or practical sense. So our second conclusion is going to be that arbitrariness is only a moral concern when the arbitrary judgments about the same individuals are enforced at scale. Okay, so when is this likely to happen? When should we be concerned about this? So the most clear case is what Kleinberg and Ragavan have called conditions of algorithmic monoculture. So this is where many decision makers all directly rely on the same algorithm. So in the same way that you can have a monoculture of crops, where the same variant of wheat is planted across acres and acres of fields, all the decision makers in the space are directly relying on the same algorithm across the sector. And it's kind of an empirical question to which the extent to which this would matter. But if the company pays extra to have the algorithm customized, let's say, we still have the same trained model as the starting point. And so we can investigate to what extent this is going to standardize the actual token outputs. We can also have a more self-standardization due to shared use of data. So sometimes, in an interesting way, best practices can lead to this phenomenon. So let's say someone creates a data set that's just obviously better, cleaner, more representative, better in a variety of ways than the other data sets that are out there. More people might start to use that data set, and then the same large data set can lead to similar artifacts or problems in different algorithms. So different models that are trained on the same data set can end up learning the same correlations and biases, and perhaps especially the same false negatives. This can also happen when there's only one set of publicly available data for something. So like there's only one US Census, there's only one EEOC credit report, for example. So a nice visual for this might be what some people call the ImageNet problem. So if everyone is training on ImageNet, you might get some of the same errors in different models. So here's, on the left, you have a fox squirrel misidentified with high probability as a sea lion. On the right, you have a dragonfly misidentified as a manhole cover. So why does this happen? Well, both of these images have really strong textures. So the fox squirrel has this wet rock that perhaps looks kind of like a sea lion, I don't know. And the one on the right has this strong cross-hatching on the lawn chair, or whatever it is, that looks kind of like the cross-hatching on a manhole cover. So the texture is helpful in making this prediction. And so if people are relying on the same shortcuts, like background textures to predict foreground objects, then you're going to get similar predictions. And we can see this, of course, in the standardization of biases, as when there are many facial recognition databases that overrepresent males, overrepresent light-skinned people, overrepresent adults between the ages of 18 and 40. And so these are going to lead to sort of predictable biases in terms of who is better recognized. So in a similar way, the overfitting to the original training data can cause this kind of arbitrariness, and then sharing the training data across models can systematize the arbitrariness. Okay, so I've posited this scenario in which the same arbitrariness is going to be shared across a wide variety of models, either because they are the same model, or because they are very similar models that have been trained on the same or similar data sets. So who is the person likely to be excluded from this? Who is the sort of algorithmic Joe? So the first thing is to say is that it could be anyone. Whatever arbitrary features in our hiring case are correlated with bad employees in the original necessarily limited training data set. And these arbitrary groups could have little in common beyond being the people who are re-identified by the algorithm or the group of algorithms. And we might think that in the hiring case, this sort of creation of arbitrary groups would be especially likely if some kind of video data was used. But it also might not be an arbitrary group. It could be that systemic arbitrariness has a disparate impact on a protected group. So someone in a racial or gender minority. So then we have a clear moral story about why this decision-making is wrong, namely that it's discriminatory. So this is going to be a separate concern from the arbitrariness, and one that we have a very good analysis of why we should be concerned about it. I think an interesting intermediate space is when you have some kind of high-dimensional data and a complex model, it can be very difficult to audit for arbitrary bias either against individuals or against tiny subgroups. So if you're this person who's kind of lost in algorithmic space down there, you're the little blue dot in the sea of red dots in the valley, how are we going to find you? So audits often only focus on federally protected categories. So race, gender, religion, veteran status. In fact, it's not typically legally mandated that you even check for one intersection. So you don't even have to check for race cross gender. But you could imagine that some kind of arbitrary exclusion might correlate with some sort of sub category that you might not be able to catch, even if you do a standard audit along single axis discrimination. So the third conclusion is that although any individual could be arbitrarily excluded, groups could also be subgroups of protected categories, and these individuals will be hard to find using our existing audits. Okay, so what do we want to do about this? One proposal is that we fight this kind of arbitrariness with randomness. So one thing we could do is we could train multiple models of different kinds, or the same kind of model on different subsets of data. So typically when people do this, they are trying to then take all these different models and learn from the different models to produce one conclusion. So the hope would not be that you would take the models individually, the hope would be that you would combine them and get this combined prediction. But we don't have to do that. We could take this basic idea and try to constrain the models to be as diverse as possible in each of their outcomes, while still retaining some kind of threshold of performance. And this is something that is sometimes called predictive multiplicity. It's something that a lot of times people are trying to get rid of. There's this concern about, wait a second, how is it that I have all these different models that are all pretty good, but they all give me slightly different results? That's not ideal. How can I learn from them and get the one final answer? But in this case, maybe we can take advantage of this. So we can say, let's choose randomly among the provisional model predictions, or we can do it with some kind of weighted average, whatever, if we think some of them are better. But then this stochasticity preserves the possibility of being classified otherwise. And so I think there are at least two nice things about this idea. One thing is that for each model, there's sort of a reason why. Philosophers like reasons, or at least a lot of them do. So for each model, we can say, from the perspective of this model, there's a reason why you were selected and other people weren't. It wasn't random in the sense that this model said you were the best candidate for the job. Another nice thing about it is that it potentially addresses the collective action problem. So if the problem that we're having is that all these individual companies, by hypothesis, are doing the best thing they can from their own epistemic perspective, then it's sort of challenging to go to any one of them and say, hey, everyone else can choose the best model, but you need to pick a different model, maybe the second best model, in order to give some candidates a chance. So how do you get people to depart from using the very best model? Well, one thing you could do is you could say, okay, everyone, or at least one person needs to use this classifier ensemble, and then by doing so, you as one person have sort of given a different candidate a chance, even if you don't know exactly what everyone else is doing, or you can't ensure that everyone else is also switching to this other system. So how would this work? Well, let's say there are 100 candidates, and maybe 10 of them are qualified, and in Model A, Alice is rejected because of some kind of arbitrary feature. But then we also have Model B, where there are still 100 candidates and 10 are qualified, but now a different person, Juan, is the one who's rejected. And so if we randomize between these two different models, then we can have different people who end up being the ones who are rejected. So this kind of multiplicity preserves our performance in the employee prediction task. If it sacrifices some performance, we also know that the domain is kind of noisy and underspecified with non-unique solutions. We don't know exactly what it is to be a good employee in all cases. So it might be that by giving ourselves a range of different models that are all trying to be different from each other, we might be capturing different features of what it is to be a good employee. But most importantly, from the moral perspective that I was trying to sketch, it decreases systemic false negatives. And I've been arguing that that's important if the model is going to be used at scale or across the sector. Thank you.
Thanks so much for the talk. So in this sort of ensembling approach that you described at the end, a lot of times for these models to work, you might need to have the decisions that are made, or this idea of like weak learners where they're not all, performing as well or as optimally. So is there some notion of that, of how do you create diversity in all the model outputs and make sure that, I don't know, they actually have differences in terms of what they'll predict?
Yeah, good. So are you saying like, do we have to ensure that we have to ensure that the models are not all learning the same things, and that, yeah, right. And so as you suggested, if in a particular case they have to be sort of weak learners or not quite as good, then yeah, this would involve losing some performance in order to get that diversity among the models in terms of their outputs. Yeah, thanks.
You talked about having different data sets, training data sets, different models to create a sense of what's the working in one model that you generate. That's where it kind of allows us to use those models to simply use consider quantitative or so that is. So this kind of purposes, those kind of use.
Yeah, absolutely. And I'm totally open to that. I'm open to whatever would make it such that we can have different instances where for the same task, different people would end up being recommended, or different people would end up being not even considered. Because what I'm mostly concerned about is that first cut of, we have thousands of resumes and throw away 900 minutes. So yeah, I'm totally open to that. That's great.
And so you are looking at people in this by learning separate ensemble models. In fact, as you were going, I just showed myself. But I also thought the problem you may which is that it is possible that it's a data. that's, it has some basic properties because of which the models learn still have assumptions. Why not actually do a more direct thing, which is take whatever model you have and see what it says are, these are should be accepted, these should be rejected, and in some extent probability things results are. And that could be another way ensuring at least that this, the arbitrariness would be avoided. But of course, it does reduce the effectiveness to some extent, but I think we are, in some sense, optimizing for something more than just the effectiveness. One time I remember going to the Paddington station with the right after the Wampins, where the Wampins happened to have been done by New Zealand cycling. And so every time I passed through, they basically either had to with my family, I was in stop, or one day I was passing for myself, they stopped me, and my God, these UK guys are basically biased. And then, as if the central casting sent an old white lady, and they stopped her and they started to see that. But I knew that no model in the world would have stopped a white lady, even if you consider that one. But I felt extremely good because I felt the justice is not only being done, it's being seen to be done. Not only that brown guy, but also this white woman stuff. So I'm wondering if we should just go in and fiddle with the positives and negatives directly, as against changing separate models.
Yeah, good. So the suggestion was, should we go in and fiddle with positives and negatives directly? Right?
Yeah, I mean,
Yeah.
the final thing, whatever it said, we should just sort of ignore some of it, epsilon problem. It's sort of like reinforcement learning expression.
Yeah, good. So you can just,
Yeah.
yeah, so you can just directly inject this. Yeah, totally. So from a statistical point of view, I get why that is exactly the same thing. But I think in terms of like a public-facing algorithm, one concern that I hear expressed pretty often that I think is reasonable is, so wait a second, there's a model that's going to produce some kind of best recommendation, and let's say, it recommended this person, but then you chose this person instead of me, even though I was recommended by the model. So I think in terms of like public-facing justification, there is some value in genuinely in saying for each person, they were the person recommended by a model, and maybe even though they are, I understand that they're very similar. I think having that at least like appeal to justificability might be better than just saying we injected some random values.
Except when you think that there's a white line to be enough, because anyway you're showing 4 models, I think you got 4 models. So you can just say one model and this noisy model that just to say these other things is we should be taken.
Okay, good. So we have the suggestion that we should our ethical solution should be that we should be government house model choosers and tell everyone that no. Okay, this is an ethics talk. We can't lie to people about how the model was chosen. So I'm going to say no. But I hear you.
More questions? Isn't one of the big problems that it's just our ability to discriminate between first-equivalent and back candidates really drop off. For minority groups, so like one of the big problems is actually that, for minority populations, we've got really high predictive, for majority population, really high predictive value, we have really good ability to discriminate. For the minority population, so it's in my mind, a lot of the problem is still about, I guess, sort of contrary to what Rob was saying about, we want to predict we want to have the same sort of predictive efficacy for minority populations as well, right?
Yeah, that seems right. And this talk is just addressing a different problem in the sense that I think you're totally right. Like the things that we would want to do in order to decrease bias or have better positive predictions are going to be a completely different set of techniques. But I think one of the reasons I picked this one is that I think it's combinable with the kind of techniques we have for improving prediction quality for minority populations. And so that is also, yeah, a really important family of fixes to do, and I'm hoping that these two things can stack.
Are you just sketching?
So there's two sort of like notions of overfitting. I think the word being overloaded is there's the conventional sense, which is you find patterns, or you think you have patterns of empirically basically finite samples. It's actually not general, it's new samples from the same distribution. And then there's the way that we use it sometimes where we really mean is it overfitting in the sense of fitting finite samples, but rather deep learning some all this non-stable changes in the environment. Changing the environment isn't a change of the sample, it's a change actually in the data generating process. And I think it's like an interesting thought to like think through just even this, let's say all that much overfitting and there is something interesting there. There's certain individuals, well, everybody uses the same data, there's maybe sort of at the same time, I think the core issues that we're actually concerned with here are not often not about accuracy. You might look at the population, I get that possible model for the population. I think the main problem don't go away to what we mean when we say arbitrary. They arbitrary, like, I think the overfitting example is one notion of arbitrary, it's like really arbitrary, it's like a bad sample, not a different kind of draw. But I think that you take that away, we still have this concern about arbitrary things. It's no longer arbitrary in the sense that subject to the draw of the sample. It's arbitrary in the sense that we think it is somehow not what makes it's not the cause of the relevant thing. So I think it's arbitrary to make it's not arbitrary to make a decision about what you use in the long based on the shoes they're wearing, not because you don't think it's predicted. It's entirely possible to look at the data and it's not about a finite sample. Everybody agrees. The example I looked at our black or law, and it turns out their shoes predict whether or not what we pay. Still think it's something wrong. What would be really when we talk about arbitrary is really about overfitting in that environment, or there's something kind of more profound and let's get into, we actually have no problem with a lot of information.
Yeah, that's a great question. Okay, good. So just to summarize, is there some intrinsic difference between arbitrary features that we catch because our sample is finite and it's not really representative in some sense of the population that we want to model, either because it was never representative or because that population has changed over time? Or should we worry about, do we need some more sort of feature-based definition that says, hey, you know what, it's always going to be arbitrary to reject someone because they have purple shoe fixes. That's just not the kind of feature that we want to be deciding on. And it's just never going to be acceptable to do that. Whether or not it's predictive, whether or not our sample that found that was representative. Yeah, I think that's a great question. So the reason that I went about it this way in this talk was sort of to pick out what's a special problem that we might have in the machine learning context. But I think you're actually right that they both could be special problems in the machine learning context as opposed to in the human decision maker context. Because it could be that maybe the human decision makers over time haven't picked up on this strange pattern that purple shoelaces are predictive. of job candidate success. But for some reason, our model does pick up on that and does want to use that as a feature. Yeah, so maybe there needs to be a sort of more base level story about what features are acceptable, like for example, causal ones. And I think that will work well in terms of just inserting that and saying that's the only sort of acceptable set of features. You would need a very different testing procedure for how to determine those features, but that's fine and maybe a good thing. Yeah.
Any further questions? Yeah, interesting. I think there's two things going on there. One is sort of like a conceptual slippage between the sort of technical notion of overfitting and maybe something else that we are indicating that overfitting having to do with truth to the world. An interesting question. I think I remember. I'm remembering now reading this stuff like 6 months ago, and I had this interesting question of maybe there's a sense of arbitrariness that's there's a sense of arbitrariness that really is terrible. There's a sense of arbitrariness that means something like randomness, right? And there's a sense of arbitrariness that means does not conform to what we kind of human academic agents think is a good reason, right? Which means something causal.
All right.
Awesome. Let's thank our speaker. Oh, sorry. Coffee and tea break. We have cookies. Back in 15.